Hello my dear students, what a joy to see you back, and such a joy that you're back victoriously after doing your quiz, and I'm so proud of you, and I'm so proud to see you so motivated that you want to learn, that you want to enrich yourself with mathematics. So good to see that. In this sub-lesson, we're going to talk about positive and negative fractions, and then we're going to learn how to add, subtract, and also multiply and divide. Okay, now let's talk about positive and negative fractions. So now first let's understand what we have learned from previous lesson about fractions. Okay, now if I have 5 and 2, what do you call this? This is called denominator. And what do you call this? Numerator. Okay, now the denominator tells you how many in a one pizza. Let's say for example we take a pizza, that pieces have been cut into. Okay, so let's say if I have a pizza right there, okay, if I cut that into 5 pieces, okay, 1 2 3 4 5, so 1 2 3 4 5, all equal shape. The 2 is pretty much the 1 2, okay, take 2 pieces out. See that? So left is 3 pieces, so that's what makes 2 over 5. See that? Alright, now that means if I say 3 over 5, which one is bigger? 2 over 5 or 3 over 5? As long the denominators are same, I can compare by looking at the numerator. 2 and 3, which one is bigger? 3, so that means 3 is bigger. See that? 3 is bigger. Okay, so that shows, if I had to show you in a number line, alright, you know that, let's say this is 0, 1, and then continue, let's say 2. If I had to show in a form of fraction between 0 and 1, it all depends how many lines I create. Let's see if I create 5 lines, okay, so 1, 1, 2, 3, 4, 5, okay, that means it's pretty much like a one piece I cut to 5 sections. 1, 2, 3, 4, 5. That means what is this one? It'll be 1 over 5, 2 over 5, 3 over 5, 4 over 5. See that? Okay? That means 2 over 5 is right here, and 3 over 5 is right here. See that? So the number is right here and right here. Okay? So which one is longer? This one or this one? Of course this one is longer. That means this one is bigger and this one is smaller. See that? Alright? Okay, so that's how you show it in a number line. And pretty much 2 over 5 is right there, 3 over 5 is right here. Now what happens if it's become a negative number? Negative fraction. So negative fraction goes this direction. Okay? So if I were to put a negative 1 right here and then negative 2 right here, see that? The number gets smaller this way. So if I had to put this into 5 parts, let's see, 1, 2, 3, 4, 1, up, they're not even. They have to be evened up, alright? So let's say 1, 2, 3, 4, 5, okay? So that means negative 1 over 5, negative 2 over 5, negative 3 over 5, negative 4 over 5. As the number goes this direction, it gets smaller. That means you owe, you know, that means you're smaller, alright? So that means negative 1 over 5, it's greater than negative 2 over 5. Negative 2 over 5 is greater than negative 3 over 5. Negative 3 over 5 is greater than negative 4 over 5. See that? It's opposite to the positive. Positive one is 1 over 5, alright, is smaller than 2 over 5, and smaller than 3 over 5, smaller than 4 over 5. See that? Or in other words, 4 over 5 is greater than 3 over 5, 3 over 5 is greater than 2 over 5, 2 over 5 is greater than 1 over 5. With the negative, look at that, how it goes. The other way around. So, with the positive, the bigger the numerators, as long the denominators are same, the bigger the number is. With the negative, as long the denominators are same, the numerator, the bigger the numerator is, the smaller the number is. Alright? See that? Negative 4/5. Smaller than negative 3/5. Or in other words, negative 3/5 is bigger than negative 4/5. But look at that. 3/5 is smaller than 4/5. Because this is positive, this is negative. Alright? So once you see the negative numbers, you're comparing with. So, and we know from our number, let's say for example, negative 3 and negative 4. Which one is bigger? Of course, negative 3 is bigger. See that? So you can do the same thing. You just take the negative 3 and you compare that with negative 4. So which one is bigger? Negative 3 or negative 4? Negative 3 is bigger. That means this one is bigger. Negative 2 and negative 3. Which one is bigger? Negative 3 is smaller than negative 2. Negative 2 is bigger. See that? That means this whole thing, that one is bigger. That's how you compare them. Alright? So I want you to understand how to compare between negative fractions. And of course, if I were to give you negative 3/8 and a positive 1/5, the moment you say negative and a positive, this is definitely going to be bigger. Alright? No matter how big or small this number is. If you see a negative and positive, okay? I can even give you something like this. Negative 345 over 375. And then I give you 1/2. Which one is bigger? This one. Don't let these big numbers intimidate you. Alright? Because this is negative and this is positive. This is going to be smaller, that's going to be bigger, no matter what. Alright, the moment you say negative and a positive, the positive number, no matter how big or small the number is, it's still going to be the biggest because bigger than the negative number. Okay, negative is always so small. Alright? Okay, good. Let Mr. Mike erase the board and let's talk more about it. Okay, I'll be back there in a few seconds. Alright, my dear students, welcome back. Now let's talk about more about comparing negative fractions. Now I also recommend, Mr. Mac strongly recommend that you also go to Form 1 fraction and understand the principle behind fractions. Okay, it's very important because on Form 2, Mr. Mac will not be emphasizing a lot about how the fraction works because it's something that we covered in Form 1 and this is a continuous from Form 1 to Form 2. The Form 1 is the foundation for your Form 2. So Mr. Mac again recommend that you revisit your Form 1 on the fraction and you have access to that. Alright? Okay, good. Now let's talk about again a negative fraction. If Mr. Mac to give you negative 5/7, negative 4/7 and I want to compare and want to find out which one is bigger. Okay, the key thing is when you want to compare two fractions, the denominator. Okay, and you know this is the denominator. Okay, so this is your denominator and this is your numerator. Okay, so we're going to use the denominator as the first step to make sure both fractions are same, common denominators. Okay, once they are common, then we're going to use the numerator as a way to compare who's bigger, who's smaller. All right. Okay, so now look at this negative. This is negative 5 and this is negative 4. Now, which would you rather have? You want to owe 4 or you want to owe 5? See that means you have less by $5 or ringgits, okay? Or would you rather be less by 5 ringgits or less by 4 ringgits? Of course, you'd rather be less than 4 ringgits because less than 5 ringgits, you're more lesser than a 4. See that? So that means negative 5 is smaller than negative 4. So overall, since both the denominators are same, okay, common, that means this one's going to be smaller and this one's going to be bigger. So I'm going to put it like that. So that's the bigger fraction compared to that. Only because it's a negative. What happens if it's a positive? Let's just translate that, okay? If this is 5/7 and 4/7, both as common denominators. Now with a positive, 5 and 4. 5 bigger or 4 bigger? Of course 5 is bigger. See that? See, can you see the difference between the negative fraction and a positive fraction? The same thing applies with a negative number and a positive number, okay? Of course, if I had a negative 5 and negative 4 and 5 and 4. And of course, you know that negative 4 is greater than negative 5. 5 is greater than 4. See that? So same thing applies towards a fraction. Be careful, the denominators has to be same. Well, you ask, Mr. Mac, what happened if the denominators are not same? Okay, let's say I have a negative 3 over 4 and negative 2 over 3. When I look at this two, there's no way I can tell which one is bigger, which one is smaller. Because why? They both don't have the common denominators. So I have to find the common denominator, convert these two fractions with the common denominators. Alright, how do I do that? Okay, I want to find the least common that 4 and 3 can be divided, which would be 12. How do I know that? I can either take 4 times 3, 12. Is there anything below 12 that 4 and 3 can be divided? No. So I can see 12 would be the least common denominator. Okay, so I put 12 here and 12 there. How do I get from 4 to 12? I multiply this by 3, am I right? If I multiply the denominator by 3, I multiply the numerator also by 3. Negative 3 times positive 3, negative and positive is negative. See that? 3 times 3 is 9. Now, how do I get from 3 to 12? I multiply this by 4. If I multiply the denominator by 4, I also multiply the numerator also by 4. See that? So, negative 2 times positive 4. Positive and negative is negative. 2 times 4 is 8. Now, can I compare? Who's bigger, who's smaller? Alright? Now, remember, negative 9 and negative 8. Which one is bigger? Negative 8. Alright? Because you owe less than you owe you more. The more you owe, that means the smaller the number that is. Okay? Alright? So that means this is bigger. Right there. Alright? It's very important. Okay? When you're comparing a negative fractions, make sure the denominators are common. Okay? Identical. If they're not, find the common denominator. Alright, now when you're comparing a negative with a positive, alright, always the positive fraction will be bigger, no matter what. Okay, even if I give you 3, 2 over 5 negative, and then this is 1 over 100. Which one is bigger? Of course this. This is, doesn't matter, the 3, 2 over 5, it's just a number, big, looks big, but this is really a small number compared to 1 over 100. Alright? Because this is positive, this is negative. If both are negative, then you have to, of course, if this is negative, this is still the bigger because negative 3, 2 over 5 is really small. Remember, you owe 3 plus the 2 over 5. This one you only owe 100. See that? So this is still the bigger, right? Okay, good. So now you really understand, don't you, how to compare two negative fractions. Alright, see that? So negative 3, 2 over 5, comparing it with negative 1 over 100. Now, what about if there's some mixed numbers with a negative? Let's say, for example, if I have a negative 2, 2 over 3, and negative 4, 1 over 5. Look at this. You don't even have to worry about the fraction anymore now. Look at this, 2 and 4, negative 2 and negative 4. Which one is smaller? Negative 4 is smaller. See that? Right away this one becomes big. If the both round numbers are identical, let's say this is negative 3, let's say 2 over 5, and then negative 3, 1 over 4. Now, this is negative 3 and negative 3. So they're pretty much the same. So you cannot tell. The deciding fraction is the one that's going to decide which one is bigger or which one is smaller. But they're not common denominator. So I have to make these two to be common denominator. So what number the 5 and 4 can be divided by? The easy way to find is 5 times 4 is 20. 20 would be the least common denominator for 5 and 4. Because there's no other number below 20 that 5 and 4 can be divided. Alright? This is from our experience with a fraction. Okay? So I'm going to make this as 20 and this is also 20. How do I get from 5 to 20? I multiply that by 4. If I multiply 5 by 4, I also, the denominator, I also multiply the numerator by 4. Okay, that makes it 8. So bring the negative 3 Alright, so same thing with this one, bring the negative 3. How do I go from 4 to 20? I multiply this by 5. If I multiply the denominator by 5, I multiply the numerator also by 5. 1 times 5 is 5. Now you compare. Now remember this negative, it belongs to all of them. That means pretty much negative 8 and negative 5. Which one is bigger, negative 5 or negative 8? Remember, we're dealing with negative. Negative 5 is bigger. See that? Negative 5 is bigger. It's kind of like the line graph, okay? So this is a line graph, and this is the 0, 1, 2, and this is negative 1, negative 2. Okay? So the number gets smaller as you go this way. The number gets bigger. Okay? Bigger, smaller. See that? So as the negative number get bigger, the overall value is smaller. As the number get bigger, the overall value is bigger for positive. Okay? So this way and that way. Alright? So there you go, right there. Okay, good. Well, let's talk about adding and subtracting using fractions. Okay? Alright, I'll be back with you in a few seconds. My dear student, I want to keep in mind in fraction, whenever you add and subtract, okay, the denominator has to be common, something we covered in Form 1 fraction. Again, Mr. Max strongly encourage you. If you think that your fraction is not strong enough and you need to brush it up, go ahead, pause this video and go to Form 1 fraction and do some revision and then come back and continue, because it's going to be tough if you don't have a strong foundation on fraction overall, okay? Because on this lesson, we're just going to go quick. We're going to move fast, alright? Because something you already learned from your Form 1 fraction, alright? Okay, alright, let's continue. If you think you're good, alright? Good. Let's do that. Now let's say, for example, if I have 3 over 4, and then let's say I'm going to have a mixed number, 4, 3 over 4, I'm adding it with 2, let's say 1 over 4, alright? In this case, the both mixed number has a common denominators, alright? 4 and 4, that means I can add them. So round number, add with the round number. 4 plus 2 is 6. And then since they both has common denominator, I bring the denominator across, and then 3 plus 1 is 4. Now look at this, 4 over 4 is what? 1. So 1 plus 6 is 7. Okay? So that makes it 7. Pretty straightforward, isn't it? Now let's say, for example, if I have 3, 1 over 2 plus 1, 1 over 3. Now look at this. The mixed numbers here, the denominators are not identical. 2 and 3. So I have to make it common denominator before I can add them. Alright? Now with the round number, I can add them. It's no problem. So 3 plus 1 is 4. Okay? Now I got to find a common denominator. 2 and 3. What would be the common denominator for 2 and 3? A number that 2 can divide and 3 can divide. A number that 2 can divide and 3 can divide. Alright? The easiest way to find is you multiply 2 with 3, which is what? 6. Okay? 6, 6. How do I go from 2 to 6? I multiply that by 3. That means I also multiply the numerator by 3. So 1 times 3 is 3. And how do I go from 3 to 6? I multiply 3 with 2. If I multiply the denominator by 2, I also multiply the numerator by 2. So 1 times 2 is 2. Now look at that, the common denominator. I can add them. Carry the 4 across. 3 plus 2 is 5. And then common denominator 6. Right there. That's it. Pretty easy, isn't it? The same thing with the subtraction, okay? If I have 6, 3 over 5, and then I'm going to minus that with 2, 1 over 3. Can I subtract this? No, because why? They're not common denominator. The denominators are 5 and 3, so I got to convert them into common denominator. But when it comes to round number, you can go ahead and subtract that. 6 minus 5 is? With the round number, you can go ahead and subtract them. Okay, 6 minus 2 is 4. Now I want to find a common denominator with 5 and 3. Exactly. The easiest way is just multiply 5 with 3, which makes it 15. 15, 5 can be divided. 15 can also divide by 3. Okay? So how do I get from 5 to 15? I multiply this by 3. If I multiply the denominator by 3, I also multiply the numerator by 3. That makes it 9 over 15. And how do I go from 3 to 15? I multiply this by 5. That means I also multiply the numerator by 5. So that makes it 5 over 15. So now I can subtract because they both has common denominator. Okay, I bring the 4 across. 9 minus 5 is 4 over the denominator you carry across. Very important. The denominator never changes for addition and subtraction. Okay, once you find the common denominator, you just carry it across. Alright? Okay, good. Now, let's talk about when you have positive and negative fraction or mixed numbers in it. Alright? And then you try to add or subtract. Okay, let's say, for example, Mr. Mac to give you, let's say 2, 1 over 3 minus with negative 1, 1 over 4. So what's the key? Combine them. Okay, when you have a negative and negative, from Mac's first law, negative times negative is positive. Alright, so then you got 2, 1 over 3 plus 1, 1 over 4. Right there. Now back to what we learned earlier. Now here, addition problem. That's the thing, you got to combine this. You cannot have two signs next to each other like this. Once you combine, get to this, then you solve it. Now it's addition problem. Okay, you can add the round numbers, but you cannot, because they're not you cannot the fractions. Why? The denominators are not identical, they're not common. So I got to find a common denominator for 3 and 4. So what would be a common denominator for 3 and 4? Very good, 12. 3 times 4 is 12. Okay, because you also, even though you times 3 times 4 is 12, you want to see if there's anything below 12 that could be make the least common for 3 and 4, but there isn't. And see, that's why multiplication timetable plays such an important role in our calculation. See that once you have the timetable in your hand, in your fingertips, you should easily solve them. Just come up with it. Alright, 3 times 4 is 12. Well, is there anything smaller than 12 that 3 and 4 can go? Because you have all your timetable in your head. Nope, none. Alright, okay. So we can say 12 would be the common denominator for 3 and 4. How do I go from 3 to 12? I multiply this by 4. That means I multiply this also by 4, the numerator. That makes it 4 over 12. How do I go from 4 to 12? I multiply this by 3. That means denominator. Then I also multiply the numerator by 3. Okay, so that makes it 3 over 12. Now I can add. Why? They both has the common denominator. I carry the 3 across. 4 plus 3 is 7. 12, you just carry it across. You do not add them, alright, or subtract them. Just 12, you just carry that across. Alright, only the numerator you add them, not the denominator. Okay, let's say let's more. Okay, let's say if I give you 3, 1 over 2, and then say plus negative 1, 1 over 3 minus negative 2, 2 over 4. Alright, let's say 3 over 4. Okay, let's put 3 over 4. Alright, right there. So now, how do we do this? Well, you use the pairing method. Okay, so we use the pairing method. We can solve this together and then with that. You could do that way. Alright, so let's start with the first two. Now let's not try to find all one shot. Okay, it could be messy. It's always good to break that down and do them piece by piece and then combine it and solve it. Come to the final answer. Alright, when you try to solve all this one shot, it's going to be tough. Alright, okay, good. Let's start with this 2 first. Okay, so always combine the sign. Do not perform anything until you combine the sign. Positive times negative, it's negative. Alright, okay, and then we're going to write this one back up again. 3, 1 over 2, 1, 1 over 3. Now you're subtracting. 3 is subtracting with 1, so that will give you 2. Okay, now can I subtract 1 over 2 with 1 over 3? No. Why? Because they're not common denominator. So I got to find a common denominator between 2 and 3. What would that be? Very good. 6. How did you get 6? 2 times 3 is 6. Okay, so how do I go from 2 to 6? I multiply that by 3. That means I also multiply the numerator by 3. That makes it 3 over 6. How do I go from 3 to 6? I multiply this by 2. That means numerator also by 2. Okay, bring the negative down, the subtraction down. Alright, now can I subtract? Yes. 3 minus 2 is 1. So first carry the 2 across, 3 minus 2 is 1, and you carry the 6 across, right there. Now we bring down and down. You got negative and negative. What makes it what? Positive. Plus 2, 3 over 4. Okay? Now, I can add the round number, but I cannot add the fraction. Why? Why cannot add the fraction? Because the denominators are not common. Okay? So let's add the numbers first. The 2 plus 2 is 4. So what would be the common denominator for 6 and 4? Well, you said, Mr. Mac, how about 6 times 4 is 24? That's a big one. There could be a smaller than 24 that 6 and 4 can accommodate. How about 12? 12 can be divided by 6, 12 can be divided by 4. See that? You always want to get to the least common denominator, alright? So, there we go, 12. Okay? How do I get from 6 to 12? I multiply that by 2. That means I also multiply the numerator by 2. 1 times 2 is 2. How do I get from 4 to 12? I multiply that by 3. So I multiply also the numerator with 3. So 3 times 3 is 9. See that? Now I can add them because they're common denominator. So that gives me 4. 2 plus 9 is 11. Bring the 12 across. Right there. It's 4, 11 over 12. That's it right there. Alright? So the key thing is what? Understanding how to combine this. Positive, positive, or negative, negative, or positive, negative, negative, positive. Once you combine them, rest of it is what? What do you learn from your Form 1 in fraction? Alright? Okay, good. Alright, Mr. Mac, erase the board. Let's talk about multiplication and division. Alright? Now again, let's recap about addition and subtraction with a fraction. What's the key thing when you add fraction or subtract two fractions? The denominator has to be common denominator, otherwise you cannot add them. Alright, you have to convert them into common denominator before you can add them. See that? See, that's what we pretty much did all the problems. We converted them into a common denominator before we add or subtract. Okay, good. Alright, let's go to next part of the lesson where we're going to learn about multiplying and dividing. Alright, I'll be back with you in a few seconds. Alright, my dear student, now with addition and subtraction we talked about they have to be common denominator in order to be able to perform the operation. Now when it comes to multiplication, let's start with multiplication. Alright, it's a bit different. It doesn't apply like what the addition and subtraction, okay, has been done. Alright, we're going to learn something new, alright, which is actually, it's something that you learn from Form 1 in fraction as well. Alright, so now let's say for example Mr. Max said 3 over 4 times 1 over 5. Whenever you multiply, we're going to use the double arrow method. Mr. Mac has something to show you. The double arrow method. It's only the Robin Hood can do the double arrow. When he shoots the target, the 2 arrow will travel parallel, straight. See that? Alright? What is double arrow method? Okay, let me, Mr. Mac, show you what I mean by that. When you have a fraction multiplying, see this double arrow? You put a double arrow like this. And you multiply. 3 times 1 is 3. 4 times 5 is 20. That's it. If you can reduce or simplify, do it. But in this case, I cannot. Is there a common number that 3 and 20 can divide it by? No, there isn't. So pretty much that's it right there. And that's what, for multiplication with fraction, you use the double arrow method. Okay? So let's say for example, if I give you round numbers with the mixed numbers. So let's say if I have a 2, 1 over 3 times with 1, 1 over 2. Now you cannot multiply mixed numbers like this. You have to convert them into improper fraction. How do we convert mixed numbers into an improper fraction? We're going to use the semi-rotation method. Okay, this is semi-rotation right there. You multiply and then you add. Multiply and then you add. What do I mean by that? 3 times 2 is 6. Plus 1 is 7. So that is 7 over 3. Remember, the denominator doesn't change. Alright? See, what we're doing is we're converting this mixed number 2, 1 over 3 into 7 over 3. And I'm multiplying that with 2 times 1 is 2 plus 1 is 3. 3 over 2. Right there. And then we're going to see if we can simplify, alright? We're going to use this bow method, alright? Remember, bow method. What is the bow method? You want to see this way, or this way, or this way, or this way. Can see if we can simplify. Look at this way. 3 and 3 can be simplified. What do I mean by that? I can divide this by 3, I can divide this by 3. Has to be a common number you can divide by, alright? Again, something we covered in Form 1, okay? On fraction. So, that will become 7 over 1 times, what is this one be? 1 over 2, because 3 divided by 3 is 1, 3 divided by 3 is 1. So now I use the double arrow method. 7 times 1 is 7, 1 times 2 is 2. This is improper fraction. So I have to convert this into exactly mixed number. So what do? We use the arrow down method, which is what? 7 divided by 2. 7 divided by 2. That's what that translates. Okay, and then we're going to use the long division. Okay, that means we're going to use the cage approach. The 7 is kind of into Mr. I'm going to put inside the cage. 2 is kind of out, I'll put outside the cage. In 7 there's how many 2? 3. 3 times 2 is 6, minus gives me 1. This is the round number. Okay, that's the whole number. 3, the 1 is your remainder, which you put as a numerator. The 2 is your denominator. Alright, keep in mind, this is your remainder balance. That goes up. The 2 is the denominator. So 3, 1 over 2. So always keep in mind, this fraction right there, see the denominator, that should remain as the same. Okay, the remainder you put it up, the 3 is the amount of 2 inside 7, which was 3. So there you go. 3, 1 over 2. Okay, so we understood how to multiply fraction and mixed numbers. Alright, now let's integrate the negative and positive numbers in it. Okay, when multiplying, I'd say if I have a negative 2, 1 over 3, and I'm multiplying that with negative 1, 1 over 5. So can I multiply this? No. Why no? Because they're mixed numbers. I have to convert them into improper fraction. Alright? Okay, good. So let's do that. What method we're going to use to convert that into improper fraction? Semi-rotation method. Alright? So we multiply first and then we add. Multiply and then add. Okay? Addition. So 3 times 2 is 6. 6 plus 1 is 7. 7 over 3. Don't forget the negative. Times semi-rotation method. 5 times 1 is 5. Plus 1 is 6. So negative 6 over 5. Alright, now can I multiply? Yes. Now do they have to be common denominator? No, not for multiplication, only for subtraction, addition and subtraction. Alright, so in this case I can use the double arrow method. But before I do the double arrow method, see if you can simplify using the bow method. Okay, see this is a bow tie. See that? Bow tie? Alright, have you seen a bow tie like that? So we're going to see it this way. We're going to see this way or up and down. See that? So 3 and 6 can be divided by what? Divided that by 3. A common number that both numbers can be divided is 3. Alright? So that will give me negative 7 over 3 divided by 3 is 1 times negative 3 divided by 3 is 2 over 5. Now I multiply. First ask yourself, negative times negative is what? Positive. 7 times 2, 14. 1 times 5 is 5. Could that be the final answer? No. Why? It's improper fraction. You don't leave your answers in the form of improper fraction. You convert that into mixed number. Okay? So we're going to use the arrow down method. We're going to read exactly it says. What does it say? 14, and this is a dividing 5. That's what that is. That's the translation of 14 over 5 is 14 divided by 5. And what method we're going to use to solve this? Long division, which means cage approach. Okay? 14 is kind of into Mr. Mac. I'm going to put inside the cage. 5 is kind of out. I'll put outside the cage. In 14, there's how many 5? 2. Because 2 times 5 is 10. Minus balance or remainder is 4. See the word I use, remainder? So that means, so how do I express this 14 over 5? This is the round number. That means the number of 5 inside 14, which is 2. The denominator is 5. The remainder is 4. Right there. That's it. The final answer is 2, 4 over 5. Okay, again, the key thing that you need to pay attention to is a negative and negative. You multiply, become positive. If this has been positive and negative, you multiply, this will become negative. You make sure you carry that negative across. Okay, if this is positive and this is negative, it also becomes negative. Make sure you put negative and carry the negative across. Alright, very important. Okay, once you determine if it's a positive or negative, just set them aside, do it without them until you get the answer, and then put the positive negative into it. Alright, or bring it in. Okay, let's say for example, if I were to have negative 3 over 4, I'm multiplying that 1 over 2. Alright, okay, ask yourself, negative times positive will be what? Right away put negative. Okay, because it's going to be negative. Now use the double arrow method, because I cannot simplify. Can I simplify this way? No, because the bow tie method, only up and down and diagonal cross, not like this. Okay, but use the double arrow method to multiply them out. 3 times 1 is 3, 4 times 2 is 8. So it's negative 3 over 8. Alright, so it's very important to remember that. Okay, because we already got the negative times positive is negative. So 3 times 1 is 3, 4 times 2 is 8. Alright, okay, good. Let Mr. Mac erase the board and we will do the division part of it. Alright, and I'll be back with you in a few seconds. Alright, my dear student, now let's talk about division of the fraction. Okay, now let's say for example, Mr. Mac to give you 3 over 4 divided by 1 over 2. Now with a division, there is an extra step that you have to perform compared to multiplication. Now remember, division and multiplication does not follow the addition and subtraction approach. Okay, subtraction, addition and subtraction, they're totally separate the way they do. You have to be common denominator in order to be able to add or subtract. Am I right? With multiplication, you just use the double arrow after you simplify using the bow method. Alright, the bow tie method. Okay, once you simplify, use the double arrow method. Now with division, you're going to use the doorknob method. What I mean by that, look at this, a doorknob right here. So what happens when I turn? See that? Okay, it's a turning. So I'm going to turn and make this division into multiplication. When I do that, this is also turned, kind of like the doorknob. When you turn, you know, the thing comes in and out. Am I right? So the same thing, this is going to turn around. So the 1 over 2 turns around, becomes 2 over 1. The 3 over 4 doesn't change, stay the same. Okay, 3 over 4 stay the same. Alright, it's the division I'm turning. I'm turning it, and when you turn it, becomes multiplication. When that multiplication, this one flips over, becomes 2 over 1. Now we are back to multiplication problem, which we learned earlier. Before we multiply using the double arrow method, we simplify using the bow method. See that? Can I simplify this way? Yes, I can divide this by 2, I can divide this by 2. Can I simplify this way? No, 3 and 1, there's nothing to divide there. And then can I simplify this way? There's nothing to simplify. Okay, so let's rewrite. 3 over 4 divided by 2 is 2. Times 2 divided by 2 is 1 over 1. See that? Now I use double arrow. 3 times 2 is 3. 2 times 1 is 2. Now I can simplify. Numbers like this, simple numbers like this, you don't have to use the arrow down and use a long division. You can ask yourself, in 3 there's how many 2? 1. Alright? And what's the balance after you take 2 out of the 3, which is 1? 1 over 2, right there. That's it. See that? If it's a big number, yes, use the long division, arrow down method, and then long division, and then K approach. Alright? Right there. That's it for division. Alright, what about mixed numbers? If I have a 2, 3 over 5, I'm dividing that by 1, 1 over 3. Can I use the knob right now? No. Again, just like multiplication, the both has to be in a form of fraction. This can be improper fraction because it's a mixed numbers. You cannot perform this operation with the mixed numbers. They have to be converted into improper fraction. When I say the word improper fraction, use the semi-rotation method. Okay? You multiply first, you add next. Multiply first, you add next. Very important. 5 times 2, 10. Plus 3, 13. So that makes it 13 over 5. And this one, 3 times 1, 3 plus 1 is 4. 4 over 3. Now use the doorknob, the rotation, the doorknob. I'm going to turn this. When I turn this, the division become multiplication. This one also become 3 over 4. I just flipped it. Alright? This one stay the same, doesn't change, okay? Now ask yourself, can I simplify by using the bow tie method? Alright, this way? No. This way? No. This way? You cannot. Only this way, okay? This way, and this way. See that? The bow. See that? But not this way, alright? Okay, only for double arrow method you use this way. You multiply with the double arrow method. 13 times 3, outside our timetable range. 13 times 3, 3 times 3 is 9, 3 times 1 is 3. So that gives me 39. 5 times 4 is 20. 39 over 20. Do I leave the answer like this? No. Why? Because this is improper fraction. Okay. Now this one I can easily figure out. 39, that's how many 20? 1. See that? If it's 2 is 40, it's less than 40, so it's only 1. Alright? So it'll be 1. And what would be the balance? Pretty much 39. I'm subtracting the 20 out because I put the 20 in the form of 1 already. See that? Left is 9 minus 0 is 9. 3 minus 2 is 1. So that means 19 over 20. See that? If I had to convert this back to the improper fraction, look at that, it will get back to the same thing using the semi-rotation method. Multiply, add. 20 plus 1, 20 times 1, 20. 20 plus 19, 39. See that? Over 20, same common denominator. Alright? Keep in mind, alright? Okay, right there. That's the final answer. Okay, so now let's do with negative and positive mixed numbers involving, alright? Well, let's divide with that. Okay, let's say for example, Mr. Mac to give you negative 1 over 6. And I'm going to divide that with negative 2, 1 over 3. Let's put a bracket so that way we can contain the negative. So let's put a bracket so that way we can contain the negative. Now, can I start performing the division? Or can I use the knob method right now? No. Why no? Because they're in mixed numbers. So we have to convert these mixed numbers into exactly improper fraction. So when I say improper fraction, what method are we going to use? The semi-rotation, alright? You multiply first and then you add. Semi-rotation, you multiply first and then you add. Okay, you got to remember that. The semi-rotation, multiply and then add. Multiply and then add. So like M-A, like math, okay? M-A-T-H, math, M-A. M is multiplication, addition is next, alright? Remember that way. Okay, so now let's convert that into improper fraction. 6 times 1 is 6, plus 1 is 7. 7 over 6. And then make sure put the negative back. Remember, when you see the negative, what should go up? Antenna, alright? Don't forget that, alright? Because it's very important, okay? We don't want to underestimate the power of negative, alright? Okay, because if you miss out the negative, it's going to be wrong. 3 times 2 is 6, plus 1 is 7. 7 over 3, negative, alright? Always maintain the denominator. Denominator never changes, okay? So it is the numerator is the one changes, okay? Now, look at that. They both are in form of improper fraction. Can I perform the division operation right now? Yes. What do? Use the knob method. I turn it. When I turn the division to becomes multiplication, what happens to this one? The 7 over 3 also turn. It flips, alright? The negative stays. Only the number, the digit, the fraction is the one that turns. Becomes 3 over 7. What about this one? Nothing happens. You just rewrite it. 7 over 6. Okay? Now, before you multiply using the double arrow method, what is our first step on multiplication? Simplify using the tie bow method. Okay? So we're going to see this way can I simplify, or this way I can simplify, or this way, this way. Let's try this way first. 7 and 7. I can divide this by 7. I can divide this by 7. 6 and 3. 3. Both can be divided by 3. See that? Okay, so let's rewrite it. Bring the negative. Be careful. Bring the negative, alright? 7 divided by 7 is 1. 6 divided by 3 is 2. Multiply. Bring the negative back. 3 divided by 3 is 1. 7 divided by 7 is 1. See, that's the purpose, to simplify, make it easy for you to multiply. Now, I can use the double arrow method, alright? But before that, negative and negative multiply becomes what? Positive. 1 times 1 is 1. 2 times 1 is 2. Which is 1 over 2, because you can just drop the positive. you can just write it as a 1 over 2. That's it. Pretty easy, isn't it? Very straightforward, okay? Pretty much the foundation, the basic part of the fraction you already learned from Form 1 fraction, alright? Go back, review it, alright? The rest of it is what? Dealing with negative integrating into it. When negative and negative multiply become positive. If this would have been positive and this has been positive and negative, positive times negative would be what? Negative. Your final answer ought to be negative. If it's a negative and positive, it's also negative. Your final answer is going to be negative. That's why I want you to pay attention. Okay? The rest of it you already learned. If you didn't, make sure you go back and review on your fraction from Form 1. Okay? Good. Now let Mr. Mac erase the board. Let's talk about the combined operation. When I have addition and subtraction, multiplication, division, if they're all together, how are we going to do that when it comes to fraction? Alright? Give me a few seconds. I'll be back with you. Alright, my dear student, now let's say when I have a combination of addition and subtraction. Now first let's write down the rule. What is the rule? Alright, which is what? Best mathematics developed at school. Best mathematics developed at school. Bracket, multiplication, division, addition, subtraction. Okay? So keep in mind, when multiplication, division comes in a problem, you use the left to right method. The same thing, addition and subtraction comes in a problem, use the left to right method. And then, of course, bracket has the top priority, alright? When it comes to between this. So you do everything inside the bracket first, and then multiplication, division, and then addition, and then subtraction, alright? Okay, good. Let's say, for example, Mr. Mac to give you 2, 1 over 4 plus 1, 1 over 3 minus, let's say, 2, 1 over 6. That's addition and subtraction in it. Alright, what do? We use the pairing method, okay? We add this two first. Always use the left to right, okay? Add this first and then perform the next operation. Okay, so let's do this two. Since this is addition, what's the principle that we apply for addition? The denominator had to be same. But you can go ahead and add the round number, the whole numbers. 2 plus 1 is 3. But can I add 1 over 4 with 1 over 3? No, I cannot. Why? The denominators are not same. So I can find a common denominator for 4 and 3. That would be 12. Okay? So I'm going to make 12 plus over 12. Now how do I go from 4 to 12? I multiply this by 3. That means I multiply the numerator also by 3. That makes it 3 over 12. How do I go from 3 to 12? I multiply the denominator by 4 and multiply the numerator also by 4. That makes it 4 over 12. Now I can add them. So that makes it 3, 7. Oh, before we do that, can I simplify? No, not with addition, alright? Addition, you cannot simplify using the bow and arrow method, okay? But addition, you cannot simplify using the bow tie method, alright? Only for multiplication, alright? Because I know you're saying, well, Mr. Mac, how about 12 and 4? And then 3 and 12. No, you can't. You just add them, alright? So 3 plus 4 is 7. You carry the denominator. Now, if you see if that's something you can simplify, you simplify right now, but not while you're adding, alright? You just add them. After you're done adding, is there a number that 7 and 12 can be divided by? No, that's it right there. Alright, now bring this one. Minus 2, 1 over 6. Now you're subtracting. Okay, 3 minus 2 is 1. What is the common denominator between 12 and 6? How about 12? 12 can be divided by 12, 12 can be divided by 6, because you're always looking for the least common denominator. See that, the word least, okay? So I'm going to make this one 12 and 12. How do I get from 12 to 12? By multiplying by 1. This one also by multiplying by 1, so that means pretty much carry the same thing down. Now how do I go from 6 to 12? I multiply this by 2, that means I also multiply the numerator by 2. That makes it 2 over 12. Now I'm subtracting, alright? 7 minus 2, carry the 1 across. 7 minus 2 is 5. The denominator you just carry across. You do not perform anything, okay? Any operation towards it. You just carry the 12 across. It's the numerator is the one you either subtract or you add. Alright? Right there. Can I simplify 12 and 5 over 12? There's nothing to simplify, okay? You leave it like that. Now, what do I mean by simplify? Let's say if I get 2, 3 over 12. I don't leave the answer like this because I can reduce this down. I can divide this by 3, I can divide this by 3, which makes it what? 2, 3 divided by 3 is 1, 12 divided by 3 is 4. That is the proper way to express it, not this. This is the unreduced, okay? You have to reduce it down to simplest form, okay? So in this case you cannot reduce it, you leave it like that, alright? So now let's say if I have negative and positive number integrated into addition and subtraction, the combined operation, okay? Let's say for example, if I were to give you 2, 3 over 5, and then I'm subtracting with negative 1, 1 over 4, and then I'm subtracting with, let's say I'm adding with a negative 1, 1 over 3. Let's say 1 over 2. Okay. So what do I do? Very good. You got 3 numbers you are adding and subtracting in it, alright? That means what method we're going to use? Good job, pairing method, okay? We're going to pair, we're going to do this one first and then we're going to do that one. Alright, when you see minus and plus in it, you just use left to right method, alright? Left to right. Okay, so we're going to, now first step, negative, negative becomes positive. Okay, let's rewrite this. 2, 3 over 5, and this one's 1, 1 over 4. Alright, now, can I add them? No, I cannot, alright? So what I have to do, I have to make them common denominator. So 2 plus 1, first I can add the round numbers but not the fractions. Alright, 2 plus 1 is 3, and then I find a common denominator for 5 and 4. So what would be the common denominator for 5 and 4? 20, very good, 20, okay? So how do I get from 5 to 20? I times this with 4. If I times the denominator by 4, I times the numerator also by 4. So that makes it 3 times 4 is 12. Now how do I go from 4 to 20? I multiply that by 5. If I multiply the denominator by 5, I multiply the numerator also by 5. So that makes it 5 over 20. Now, can I add them? Yes, I can add them. Okay, so that makes it 3. 12 plus 5 is 12 plus 5. 2 plus 5 is 7. Bring the 1 down, so it becomes 17 over 20. Carry the denominator across. See that? Pretty easy, isn't it? Okay? Alright, good. Well, let Mr. Mac erase the board and we'll talk about combined operation with multiplication and division. Alright? Okay, give me Mr. Mac a few seconds and I'll be back to you. Alright, my dear students, now let's talk about combination of division and multiplication and division in a problem. Alright? Okay, let's say for example, if Mr. Bank to give you 2, 1 over 3 and dividing it with 1, 1 over 2 times it with the 1, 1 over 4. It's like, whoa, Mr. Mac! It's actually very easy. When you have 3 numbers, there's something like this. What method do we use? The pairing method. That's it. Just pair them. Do this first and then combine it with that. That's it. Alright, let's do it. Okay, we're going to divide first. Alright, so when we are dividing, can it be a mixed numbers? No, it has to be in a fraction format. So in this case, it will become improper fraction. So we're going to use the semi-rotation method. When I say semi-rotation, ma, okay? Multiplication and then addition. Semi-rotation method, multiplication and then addition. Very good. Okay, so 3 times 2 is 6 plus 1 is 7. 7 over 3 divided by 2 times 1 is 2 plus 1 is 3. 3 over 2. So now I can use the division principle. What is that? Rotation, the doorknob. Okay, we're gonna turn that division into multiplication. This one flips, becomes 2 over 3. This one stays the same. Now I use the double arrow method. 7 times 2 is 14. 3 times 3 is 9. Alright? Now, don't do anything. Just leave it the way it is. Then bring this one down. Alright? But before I bring this one down, but this is what? Mixed number. Alright? So mixed number, I cannot multiply. So I have to convert this also into improper fraction using the semi-rotation method. And then which means multiplication first and then addition. 4 times 1 is 4 plus 1 is 5. So that makes it 5 over 4. We're going to multiply. Alright? Okay, so now can I simplify before I multiply using the bow tie method? Alright, can I simplify this way? Can I simplify the, yes, this one, divide this by 2, divide this by 2, that makes it 7 over 9 times 5 over 2. Now I can do the double arrow method. 7 times 5 is 35, 9 times 2 is 18. See that? Now look at that. In how many 18 is inside 35? You know that 2 18 makes what? 36. But this is 35. So that means there was only 1 18 can fit in. Okay, that means 1. And what would be the balance if I take 18 out of the 35? Just subtract them. 35 minus 18. I borrow 1 because I cannot subtract 5 with 8. So it becomes 15 minus 8 is 7. 2 minus 1 is 1. So it becomes 17 over 18. That's the final answer. You know, it's easy, isn't it? Alright, so you just use the pairing method. Okay, now if I integrate negative and positive numbers in it, okay, let's do that. Okay, let's say if I give you negative 3 1 over 2 times with negative 2 1 over 3 and then divided by negative 3 over 4. So how do I do something like this? Again, use the pairing method. Okay, we're going to pair this and then we're going to pair with that one, and then we perform the operation. Okay, so we're going to perform this pair operation first after we're done, and then we're going to do that. So let's start with this one. Okay, now look at that, we are multiplying and they're both in a what format? In a mixed number. Alright, and we cannot do that. So what do you have to do? We convert this whole thing into improper fraction. When I say the word improper fraction, use a semi-rotation. Semi-rotation, that means ma, which is multiplication, addition. Semi-rotation, ma, multiplication, addition. Okay, 2 times 3 is 6, plus 1 is 7. 7 over 2, bring the negative back. Times 3 times 2 is 6, plus 1 is 7. 7 over 3, bring the negative back. Alright, now can you simplify using the bow tie method? 7 and 2, nope. 7 and 3, nope. 7 and 2, nope. 7 and 3, no. That means I can use the double arrow method and multiply them. Negative times negative, positive. 7 times 7, 49. 2 times 3, 6. Alright, so now I'm done with the multiplication part. Now I'm going to bring this one down. But look at this, negative 3 over 4. Is this in a form of mixed number? No, it is in a fraction already. So I don't have to do anything, just bring it down. Alright? So I'm just going to rewrite. Take this one, I'm going to put 49 over 6, because this whole thing becomes 49 over 6. Right there. So this whole thing right there. Okay? Now I take this one, divided by negative 3 over 4. Alright? Since both are in a form of fraction, actually this one's improper and this is fraction, I can use the divisions principle, which is what? The doorknob method. So I'm going to twist that division. Okay, I'm going to turn, and that becomes multiplication. When I turn multiplication, this one's what? Also turn, becomes, stays negative, except the number becomes, the fraction becomes from 3 over 4 becomes 4 over 3. Okay, 49. Okay, 49 over 6. Now, can I simplify? I can divide this by 2, I can divide this by 2. See that? Divide this by 2, divide this by 2. But this one I cannot. Alright? Positive and negative, multiply gives me what? Negative. I use the double arrow method. Okay? But keep in mind, 6 divided by 2 is 3. Okay? This one becomes 3, this one becomes 2. So 49 times 2, long multiplication. We take 49 times 2, 2 times 9 is 18, 8 carry 1, 2 times 4 is 8, plus 1 is 9. So it becomes 98. 3 times 3 is, very good, 9. So it becomes 98 over 9 negative. Negative 98 over 9. See that? How do I get 3? Because 6 divided by 2 is what? 3. 4 divided by 2 is 2. Double arrow method. 49 times 2, 98. 3 times 3, 9. Now, do I leave it like this? No, because this is an improper fraction. So I have to simplify, convert that into mixed numbers. Alright? So, what method are we going to use? The arrow down method. We know the answer is going to be negative. So we're just going to take 98 divided by 9. Okay? So we're going to take the 98 divided by 9, alright? And then we're going to use the long division method. When I say long division, what method are we going to use? What principle are we going to use? Now when I say long division, what method are we going to use? The cage. Okay, so we got 98 divided by 9. So what approach are we going to use? The cage approach, alright? So we're going to put the cage. 98 is kind of into Mr. Mac. I'm going to put inside the cage. 9 is kind of out. I'll put outside the cage. Now ask yourself, in 9 there's how many 9? 1. 1 times 9 is 9. Minus give me 0. I bring the 8. In 8 there's how many 9? 0. See that? And this is the remainder. This is the number of 9 inside. This is 9. 9 is the denominator. The 10 is the number of 9 inside 98. That means 10 times. Okay? That means this one becomes negative 10. The denominator stay the same, 9. The remainder is what? 8. Goes as a numerator. See that? Very important. Able to convert this back to this. Okay? This 10 tells how many 9 inside 98. There are 10 of them. 10 times 9 is what? 90. See that? 10, 9 inside 98. So that's what the round number. Okay? The remainder is right here. 8. The denominator. This should give you the hint. 9 is the denominator. Always stay the same. Okay? Good. Wow. That's a lot of things we learned today, alright? Okay, what tells you? It should be time for, you're right, hands-on practice, okay? Alright, good. Let Mr. Mac erase the board and I'll come back. Oh, wait a minute, before we do that, let's peek and see what Pablo's doing. Whoa, he is busy putting hands-on practice together for us. He works hard because he wants the best for you. Because you are the best, you deserve the best, and it is coming from the best. Alright, my dear students, give us a few seconds and we'll be back and we can do some hands-on practice. I'll be back. Alright, my dear student, are you ready for some hands-on practice? Alright, let's do it. Well, you or me? Call Pablo. I'll call Pablo, alright? Okay, Pablo, come on over, Pablo, come on over. Come on over, Pablo. Our dear students are anxious, they're ready to do the hands-on practice. And they're prepared. They've been learning so much, and here it is, my dear students. Alright, go get them, okay? And once Pablo gives a worksheet to you, be sure to pause the video and then do it and then come back and invite Mr. Mac in and we'll work together. Alright, here it is. Alright, oh good. Whoa, not bad, isn't it? Pablo's been working hard putting all these questions for us. Alright, okay, let's do it, okay? Then our first question says calculate. You're given A, 1A, you're given negative 4 over 5 plus 1 over 2 plus negative 1 over 4. So what do? You got 3 fractions you are adding. Use the combination, okay, or the pairing method, okay? We're going to use the pairing. We're going to pair with this and then we're going to pair with that. Alright, so it means we're going to solve this first and then later we're going to do that one. Okay, now can I add them? No, why? Because they're not common denominator, alright? So what I have to do? I have to find a common denominator for both of them. Would be what? 5 and 2. 5 times 2 is 10. Can it be any smaller than 10 that 5 and 2 can get in? No, 10 would be the perfect. So I'm going to put 10 plus with 10. How do I get from 5 to 10? I multiply this by 2. That means I also multiply the numerator by 2. So 4 times 2 is 8. Make sure you bring the negative back. And then how do I go from 2 to 10? I multiply that by 5. That means I multiply the numerator also by 5. 1 times 5 is 5. Okay, now I can add them. Why? Because they have common denominator. Now look at that. Negative 5 plus with 5. Oh shoot. Look at this. Negative 8 plus 5. Negative 8 plus 5. I owe 8 and I have 5. That means I apply that 5 that I have towards what I owe. Okay? But still I'm going to get a negative. Am I right? Because negative is greater than the positive here. So so it'll be 8 minus 5 will be 3. See that? That's what you do. You know between negative 8 and positive 5, when you combine, your final answer is going to be still negative but less than the negative 8. So what you do is you take the 8 minus 5 is 3. There you go. Then bring the denominator back, 10 right there. Negative 3 over 10. Now we're going to bring this one down. Now look at that. Plus and minus. Positive and negative. Multiply becomes negative. So it'll be negative 1 over 4. We're going to bring it down. Okay? Now can I subtract or add them? Can I combine them? No. Why? Because they're not common denominator. So what would be the common denominator for 10 and 4? Well, of course, you say 10 times 4 is 20. 10 times 4 is 40. But that is too big. We want the least common denominator. What about 20? Because 20 can be divided by 10. 20 can be divided by 4. See that? So I can use 20 as my common denominator. How do I get from 10 to 20? I multiply that by 2. That means the numerator also I multiply that by 2. So negative 3 times 2 will be negative 6. And how do I go from 4 to 20? I multiply that by 5. That means numerator also I multiply that by 5. 1 times 5 is 5. Now look at that. They both are common denominator. See that? Then I can combine. I owe more. Am I right? So that means what? I owe 6 and I owe 5. That will mean I'm going to have a negative. 6 plus 5 will be 11. So it's going to be negative 11. Okay? Over 20. You just bring that 20 across. Right there. That's it. Pretty easy, isn't it? Okay? Let's look at B. B, you're given negative 1, 3 over 4. And you're subtracting with negative 2, 2 over 3. Okay? So when you have something like this, combine the sign. Negative and negative becomes positive. Okay? That means negative 1, 3 over 4. You're adding it with 2, 2 over 3. Now when you have something like this, you can rearrange. In other words, I can bring this one over here. Make sure you carry the sign along with it. Because, see, plus 2, 2 over 3, when you put it in the front, you can drop the plus. Because this is still a positive. See that? But when you carry the negative on this side, you have to put it there. 1, 3 over 4. See that? Alright, now what? 2 minus 1 is 1. Can I subtract them? No, because they have to be in common denominator. So, I have to find a common denominator for 3 and 4. So what would that be? 3 times 4 is 12. See that? That would be the least common denominator. So I'm going to put 12 and 12 minus. Alright? So now, how do I get from 3 to 12? I multiply that by 4. That means I'm going to multiply this also by 4. Alright? So 2 times 4 is 8. And then how do I get 4 to 12? Multiply that by 3. That means I'm going to multiply this also by 3. 3 times 3 is 9. Now look at that. 8 over 12 minus 9 over 12. I cannot subtract that because this one is small, this one is bigger. I have to borrow from that. Because there's a number that I can borrow. If there isn't, then I can put a negative. Okay, in this case I can borrow. So this one will becomes 12 over 12. Remember, this is 12 over 12, which is 1. And I'm adding it there with 8 over 12. That means I can subtract that with 9 over 12. 12 plus 8 will be what? 20. Okay? 12 plus 8. 2 plus 8 is 10, 0 carry 1, 1 plus 1 is 2. So that makes it 20 over 12 minus 9 over 12. So 20 minus 9, okay, let's line it up. 20 minus 9, 0 minus 9, cannot borrow from 2, 2 becomes 1, 0 becomes 10, 10 minus 9 is 1, bring the 1 down, becomes 11. Becomes 11 over 12, right there. That's their final answer. See that? Pretty easy, isn't it? Okay, pay attention, alright? When all this negative and everything, you can move things around like what we did right here, okay? We kind of turned around, alright? As long as you keep the negative with it. Okay, it will be a lot easier. That's the beauty about mathematics. As long as you know the principle, you obey the rules, and you follow by the rules, and you do it right, you'll get to the answer. And that's the thing about it, is that you use your skill, all the things that you learn, and put them to work. Alright, good. Let's look problem C. Okay, so we already did B. Now let's go to C. Now C, you're given 3 over 5 divided by negative 1 over 3. Now both are in a form of fraction. Okay, that means I can divide. I can use the division principle. What is that? Doorknob. So I'm going to twist that. I'm going to turn that. Division becomes multiplication. What happened to this one? Also flips. Okay, reciprocal. But the negative stays the same. Just that become 3 over 1 and remain. This one remain the same. Doesn't change. All right. So now I can use the double arrow method. Positive and negative will give me negative. 3 times 3 is 9. 5 times 1 is 5. Alright, because Mr. Mac already know that by using the bow method I cannot simplify. 5 and 3 I cannot simplify. 3 and 1 I cannot simplify. That's why I went and multiplied it. Alright, am I going to leave the answer like this? No, because this is improper fraction, because the numerator is greater than the denominator. How many 5 in 9? 1. What will be left? 4 over 5. See that? Alright, because in 9 there's how many 5? 1. See that I put 1 as a round number. Okay, so if I take 5 out of the 9, left is 4. Or in other words, you can use the long division method. But this is a simple number like that. I want you to take time by doing the long division, the Cage approach, and try to get to this. Just, you can look and you should be able to solve it. Okay, alright, good. Problem D. Alright, let Mr. Mac erase the board and we'll do problem D. And I'll be back within a few seconds. Alright, my dear student, ready for problem D? Now problem D, you're given negative, okay, D is negative 3 over 8 times negative 3 over 4. Alright, so is there anything I need to do before I can multiply? There is nothing to do. Okay, I cannot simplify because this is already in a fraction. That means I don't have to do anything, and then I can see if the bow method, the bow tie method, 3 and 4 I cannot simplify, 3 and 8 I cannot simplify, 3 and 8 or 3 and 4 I cannot simplify. So I'm going to use the double arrow method. Negative and negative is positive. 3 times 3 is 9, 8 times 4 is 32. That's it right there. Pretty easy, isn't it? Straightforward. Alright, let's look at E. E, you're given negative 2 1 over 5 times 1 4 over 11. Now this is in a form of what? What type of numbers are this? Mixed numbers, alright? You got a round number, a whole number, and a fraction called mixed numbers. Can I multiply mixed numbers? You cannot. You have to convert that into improper fraction. When I see the word improper fraction, you go use the semi-rotation method, multiply, addition. Improper fraction into, I'm going to use the rotation method, multiply, which is we're going to multiply and then add. Okay, so we're going to make this one first. So 5 times 2 is 10 plus 1 is 11. 11 over 5. Negative. Bing. Alright, pay attention. Alright, okay, 11 times 1 is 11 plus 4 is 15. 15 over 11. See that? Okay, because I times 11 times 1 is 11 plus 4 is 15, and I carry the denominator. Denominator doesn't change. Now I can multiply using the double arrow method. Before I use the double arrow method, can I simplify? Can I use the bow tie method? 11 and 11. Yes, I can divide this by 11. I can divide this by 11. I can divide this by 5. I can divide this by 5. Now look what happens. Negative 11 divided by 11 is 1. 5 divided by 5 is 1. 15 divided by 5 is 3. 11 divided by 11 is 1. Look at that, how simple it became. So now I can use the double arrow method. Negative and positive gives me negative. 1 times 3 is 3. 1 times 1 is 1, which is what? Negative 3. That's the purpose of simplifying. Alright, if not, look at that, 11 times 15, 5 times 11, a huge number, and then you got to simplify it, to get to the negative 3. See that? That's the purpose of the bow tie method right away. With the simple numbers, you simplify first, and then you get to this, then use the double arrow, get to the answer. It's a lot easier. That's the purpose, okay, with the bow tie method. Alright, let's do F. F, you're given negative 2 3 over 6 divided by negative 1 over 8. Look at this problem. It's a division problem. Can I start performing the division? Can I apply the division principle? No. Why no? Because they are in a form what? In a form of mixed numbers, alright? When they're in a form of mixed numbers, we have to convert that into improper fraction. When I say the improper fraction, what should come to your mind? The semi-rotation method. When the word semi-rotation, multiply first and then add. Multiply first and then you add. Ma. M is multiply, A is for addition, alright? 6 times 2 is 12 plus 3 is 15. So 15 over 6, negative, ding, ding, then 10 out, negative, alright? Make sure you put the negative back and then put the bracket. So the negative will contain inside. 8 times 1 is, 8 plus 1 is 9. So 9 over 8, ding, ding, negative, like that. Make sure you put the negative in there. Alright, now can I perform the principle involved for division? Yes, which means what? We're going to use the doorknob. We're going to twist it, we're going to rotate that. That means that also rotates. So becomes division becomes multiplication. 9 over 8 becomes reciprocal of 9 over 8 become 8 over 9. Bring the negative. The same thing. This one bring the negative, but nothing changes. 15 over 6. Now ask yourself, negative times negative, positive. Alright? Can I simplify? Yes, you can. Alright? I can divide this by 2. I can divide this by 2. I can divide this by 3. I can divide this by 3. See that? So that gives me what? 15 divided by 3 is 5. 6 divided by 2 is 3. 8 divided by 2 is 4. 9 divided by 3 is 3. See, I already decided negative times negative is positive. That's why I put a positive. I just put the numbers out this time. Now I can use the double arrow method. Alright? 5 times 4 is 20. 3 times 3 is 9. Am I going to leave the answer like this? No. Now what about plus? You just drop it because that's a positive number. So we just leave it as a 20. I mean, we don't have to put that plus. But can we leave as a 20 over 9? No. Why no? Because it's an improper fraction. We have to convert that into mixed number. Alright? So we're going to use the arrow down method, which is 20 divided by 9. Okay? So let's use the cage approach. 20 is kind of into Mr. Mac. I'm going to put it inside the cage. 9 is kind of out. I'll put outside the cage. In 20, there's how many 9? 2. Because we know 2 times 9 is 18 minus the balance is 0 minus 8. I cannot borrow from 2. 2 becomes 1. 0 becomes 10. 10 minus 2 is 10 minus 8 is 2. 1 minus 1 is 0. This is the balance, remainder. This is the number of 2 inside 20. Okay, that means 2. And what's the denominator? 9. 9 right there. See that? The 9 stays. The balance is your numerator right there. That's your final answer. Okay? Good. Alright, let's do problem number 2. But let Mr. Mac erase the board and I'll be back in a few seconds. Alright, problem number 2a. Okay, the 2 you're going to evaluate. Alright, 2a, you're given negative 2, 1 over 3 plus negative 1, 1 over 4, and then minus negative 2, 5 over 6. Should this problem intimidate you? No way. That's what you're going to say. No way, Mr. Mac. This is an easy problem. What's our first step ought to be? Pairing method. We're going to just pair them. Alright, we're going to do this 2 first and then with that one. Alright? Okay, because both have plus and minus, so we're just going to use the left to right method. Okay? Because we don't have a multiplication division in there, so we're going to just perform the addition and subtraction. Okay? Left to right. So we're going to combine this 2 first and then with that. Alright? Now look at this. Plus and minus. You have to take care of that first. You can have 2 sign like this. So let's rewrite this 2 first. Negative 2, 1 over 3 plus times minus, or positive times negative, it's negative 1, 1 over 4. Before I combine this, ask yourself, can I combine the round numbers? Yes, okay, because this is just kind of combining, alright? You're not multiplying, dividing. So you don't have to change this into improper fraction like you did with the multiplication and division. With addition, subtraction, you can continue to perform the operation with the round number, but when it comes to fraction, you have to pay attention. And what it ought to be? The common denominator has to be common, alright? But we can go ahead and combine this two. I owe 2 and I owe 1. I owe more, alright? That means 2 plus 1 is going to be 3, negative. Now we're going to find a common denominator for both of them, alright? Which will be what? 3 and 4. What's the common denominator for 3 and 4? 12, okay? 3 times 4 is 12. So we're going to have 12 as that common denominator, alright? Okay, so we know that. How do we get from 3 to 12? We multiply that by 4. So I'm going to multiply the numerator also by 4, okay? So that becomes 4 over 12. And what about 4? How do I get 4 to 12? I multiply that by 3. That means the numerator also multiplied by 3. So it becomes 3 over 12. Now, pay this attention, alright? This is also negative. This is also negative. Pretty much you're combining. And that's why this is negative right there. Alright? So we're just going to add this 2. Because the total is going to be a negative number. Alright? Pay attention. So those are things that you need to pay attention. What I'm doing is I'm combining, because this is negative, this is negative. So the final answer is going to be negative, so I'm just going to add that. Just like add 2 plus 1, which is 3. So I'm going to add this 2. Okay? So that gives me negative 3, 4 plus 3. Because they both has common denominator, now I can add them. 4 plus 3 is 7 over 12. Right there. Okay? So now I'm going to bring this one down. I'm going to combine that with that. But look at that. Negative and negative will becomes what? Positive. Okay? So plus 2, 5 over 6. So negative and negative become positive 2, 5 over 6. When you have a problem like this, first, before you do the addition and subtraction or anything, okay, because you got a negative number, you're adding in a positive number. See that? Negative and positive. First, convert this both into common denominator. Alright? So what would be the common denominator for 6 and 12? 12. Because I can divide 12 by 12, I can divide 12 by 6. Okay? So that means I'm going to put 12. So let's bring back the negative 3 and positive 2. Now, how do I get from 12 to 12? Multiply that by 1. That means I'm going to multiply that also by 1, which is pretty much 7 over 12. I'll bring it down. Now, how do I get from 6 to 12? I multiply that by 2. Then I multiply the 5 also by 2, which gives me 10 over 12. Alright? Now, once you have in this format, where they both are common denominator, since you got a negative and a positive, the best way to do is convert all of them into improper fraction. It's easier to combine that way because you got negative and a positive. You got a bigger negative and a smaller positive. It's going to help you better if you make that into improper fraction. The moment I say improper fraction, you're going to use the semi-rotation method. 12 times 3 from our timetable, 36 plus 7. So 36 plus 7, line them up. 6 plus 7, 13. 3 carry 1. 1 plus 3 is 4. So that gives you 43 over 12 negative. Alright? Do the same thing. 12 times 2, 24. 24 plus 10. So line it up. 24 plus 10. 4 plus 0 is 4. 2 plus 1 is 3. So that gives you 34 over 12. See, I converted this both into improper fraction. Now, it's a lot easier to combine them. You owe 43 and you have 34. So you know your final answer is going to be what? Negative. Because you have a bigger negative number than a positive number. Alright? So you know it's going to be negative, but it's going to be lesser than 43 because you got positive 34. That means you're going to take 34 out of 43. That means I'm going to subtract. So I'm going to take 43 minus 34. Alright? So because I know the final answer is going to be negative. That means I'm going to take 34 out of the negative 43. Alright? So let's subtract that. 3 minus 4, I cannot borrow from 3. 4 becomes 3. 3 becomes 13. 13 minus 4 is 9. 3 minus 3 is 0. So that gives me 9 over 12. See that? Does that make sense to you? Alright? Okay, now you simplify. I can divide 9 by 3, I can divide 12 by 3. Okay, because this is not in a simplest form. You can't leave the answer like this. Alright, that means negative 9 divided by 3 is 3, 12 divided by 3 is 4. So, final answer is negative 3 over 4. Alright? See that? This one's a bit different than what we used to do. I changed it to this way, this one to this, which you know how to do it. It's just easier to combine them because you got a big negative and small positive, and you know your final answer is going to be negative. but it'd be easy if you make them all to improper fraction with a common denominator. Then you can combine the top one with a negative and a positive, gave you what? Negative 9 over 12. But negative 9 over 12 is not a reduced form or simplest form. You divide this by 3, divide that by 3, 9 divided by 3 is 3, 12 divided by 3 is 4. Bring the negative back, like that. Pretty easy, isn't it? Straightforward, okay? Good, let's do problem B. Now, problem B, you're given negative 1, 1 over 4, divide that by 2, 4 over 8, and then I'm going to multiply that with negative 1, 1 over 2. So what do I do? Exactly. This, we're going to use the pairing method, okay? That's going to be our first step, because what, you got 3 mixed numbers. Alright, so with the division and multiplication operation has been applied, and we're going to use the left to right method. Alright, so we're going to combine this and then we're going to do that one. Okay, keep in mind. So we're going to start with this 2. So negative 1, 1 over 4. I'm going to divide that with 2, 4 over 8. Can I perform the division operation and apply the principle, the division principle? No. Why no? Because it's in a mixed number. That means what we have to do? Use the semi-rotation to convert that into improper fraction. When I say semi-rotation, multiply, add, addition. Multiply and add. See that? 4 times 1 is 4, plus 1 is 5. So that gives me 5 over 4. Bing, negative. Don't forget that. Divide. 8 times 2 is 16, plus 4 is 20. 20 over 8. Alright? So now, they both form a fraction, improper fraction. And division, I'm going to turn that into multiplication. Turn, this one also turn, become reciprocal. 8 over 20. This one stay the same, 5 over 4. Now, before I multiply, use the double arrow method. I'm going to use the bow tie method. Simplify. 5 and 20. I can divide this by 5. I can divide this by 5. I can divide this by 4. I can divide this by 4. See that? I can simplify this way. I can simplify this way. So that gives me negative. Let's put the negative. 5 divided by 5 is 1. 4 divided by 4 is 1. Times 8 divided by 4 is 2. 20 divided by 5 is 4. Okay, can I simplify this way? Yes. I can divide this by 2. I can divide this by 2. So that gives me negative 1 over 1 times 2 divided by 2 is 1. 4 divided by 2 is 2. Now I can use the double arrow method. Negative and positive gives me negative. 1 times 1 is 1. 1 times 2 is 2. Now I only did this part. And I got this one to do. Okay? So I'm going to take this one, negative 1 over 2. I'm going to multiply that with negative 1, 1 over 2. Can I perform the multiplication operation in this? No. Why? This one's still in a form of mixed number. So I'm going to change that to improper fraction. That means semi-rotation method, multiply, add. 1 times 2 times 1 is 2, plus 1 is 3. So negative 3 over 2. See that? 2 times 1 is 2, plus 1 is 3. Bring the denominator. And then I'm going to multiply that with negative 1 over 2. Okay, now look at this. Negative times negative is positive. Double arrow method. Can I simplify? No. So I use just a double arrow method. 1 times 3 is 3. 2 times 2 is 4. So the final answer is 3 over 4. You got it? Good job. That's a good problems, alright? Those two are good problems. Awesome. Well, the moment Mr. Max said, wow, look at Pablo. He's already like, yes, it's time for quiz. Yes, it is time for quiz. Yes, my dear students, I'm so proud of you. You're doing so well. And this should prepare you for what? For the quiz, okay? Go get them, all right? Because you are the best. And you should be able to do all the quizzes well. After you're done, come back and see Mr. Mac, all right, on the next sub-lesson. And I'll be here waiting for you. And Pablo just dared you. He said, make sure you do your quiz, all right? Before you come see Mr. Mac. All right, before you go see Mr. Mac. Thank you, Pablo. All right, my dear students, I'll see you after you've done your quiz, all right? And then take a nice break before you come back. I'll see you. Bye-bye.